In the previous session, you have completely written an AXI write address agent, and what is remaining is write data, write response, read address, and read data agents. I will not be elaborating all these agents because all of them are similar to that whatever you have learned in the previous session. But the main functional point which are different from the previous one, which I will be explaining, all other parts I will be covering very quickly. So first we will add the write data agent, and its code is exactly same as that of the write address agent. The only difference will be while driving this data. So from the manage sequence transaction, when you drive data, you have to consider the length of the transaction. So for till the transaction length is equal, so you have to drive this data, all these fields. This is data, and the last is derived as fi is equal to length of id minus 1. Then after that you will wait for a clock cycle, then wait for ready to be accepted, and everything will be repeated within this for loop. So this is the main difference, or the main functional difference in the write data part. Rest everything is exactly same as that of the write address agent. Now coming to the slave driver, again this is exactly same as that of the write address agent, because here again you will be simply driving the ready signal. So this part is exactly same except the names. Again, now coming to the monitor part, we'll quickly go over the monitor. The monitor will be having the interface and analysis port, and in the run phase, after the null pointer check and the reset, you will monitor the data where in a forever loop. What you will do is you will wait for a write valid and write ready. You will create a transaction, and you are using a temporary data queue, because you have to accumulate a set of data together until the WLS coming in the interface. For that, you are using a temporary data queue, and first you are making sure this data is empty at this point. So this will be relevant when this is coming to the next part. Otherwise, you will mess up things. So to make sure that you are not doing anything wrong here, first you will check this size is this temporary queue is empty here, and flag an error otherwise. And first then you will delete this thing. This is again required when you iterate this multiple times, and this is the main functional past. While this is while a last is coming in this interface, you will push back this current data into the queue, wait for the next clock cycle, and also you'll make sure that this valid and ready is again high in the next clock cycle. So if it is going low, you'll wait here, and this is repeated until the last is seen in this interface. So at that point, when last is seen, you'll again push the current data into this queue, and at this point you know the length of this transaction, which will be equal to the size of this temporary data queue, and then you will create the transaction data dynamic array with this length, and you will push you will fill this data with this data that is present in this temporary queue by popping them. And again, this is another additional check to make sure that this temporary data queue size is empty here. You haven't messed up things here, and we are flagging an error if it is not empty. This is just an additional safety thing. If you don't want, you can omit it. And finally, I'm printing this information, this newly created transaction and the newly derived transaction using the convert to string function in the transaction. And finally, it's important to write this transaction into the analysis port that is present in this monitor. So here is the main functional part of the write data monitor. As you have seen here, it need to be iterated over multiple times while the last is coming in this interface. Now the AXI agent part is exactly same as that of the write address agent, so I will not be covering this in detail. You can see that the same names are written here. Only difference is the data, the name of the interface, and things like that. So all based on the configuration, you will be creating them appropriately. Then you will be connecting them appropriately. Next will be the AXI write response agent. So here is the code. So again, we will not go through them in detail, but in case of the write response agent, the TP part, our TP part need to be acting as a slave part, and therefore we'll be going in through the implementation of the slave driver, which is accepting transactions from the sequence. So first you will quickly go through the master driver. This is not used in the environment, but still you have to define it for the completeness. This is exactly same as that you have seen in the previous cases. And here I haven't filled this actual driving part. So if you are using that, you have to fill this driving part here. And otherwise it's exactly the same. And the interesting thing will be the write response slave driver. The slave driver, before writing the slave driver, let's define the protocol with which it is communicating with the sequence. So the idea here is a sequence will be sending a transaction from the sequence, and whenever a response is available in this interface, the driver need to fill those transaction fields and send it back to the sequence. So this is the idea behind developing the slave driver. Now let's go through the code. So after the component factory registration macro, it got the interface and config, and new function. There is nothing, no intelligence in the new and build phase function, and in the run phase function, after the null check and initialization and waiting for reset, you are forking two tasks which will manage sequence transaction and drive ready. This is again slightly different from the previous slave drivers, because in the previous cases we are just driving ready randomly. So that drive ready part is again written here. So this logic is exactly similar to that you have seen in the write address and write data channels. It is based on the configuration. Either we are always driving ready or we are driving ready randomly. But let's see the other task, the manage sequencer transactions. So this slave driver will be waiting for will be communicating with the sequence. Therefore it need to manage these transactions. So what it will do is, on every positive edge of this, on every clock cycle of this interface, if there is a valid response and valid ready is available in this interface, then only it will fetch the next item from this sequencer. So sequitem next item will be called only when there is a valid thing is available. So this will make sure that once a sequence is sending a slave response transaction at time 0, this will be it will not be pulled into this driver until a valid response is available in the interface. Once a valid response is available in the interface, it will pull the next item, the next transaction, and see whether it is a right transaction, then the channel is correct, the right response channel, and also it will see whether the transaction is requesting a response. Generally it will send the response. So the sequence should explicitly say that the transaction is requesting a response. And if all these criteria are satisfied, then the transaction.id will be filled with this ID that is available in the interface, and the response will be filled from this interface as well. Then it will send this transaction back to this sequence by using the sequitem pointer. Since the same transaction is filled with this data from these interfaces, when the sequence complete the finish item code, it will have all this information in the sequence. So this was the manage sequencer transaction task in case of a slave driver, which is actually communicating with the sequence. This we have already seen, and the monitor is again similar to that you have seen in case of a write address agent. So you can see that it's similar, and again the final agent, it's again similar to those two previous agent you have seen, the write address and write data agent. Based on the configuration, you need to build things correctly and you need to connect things correctly.